Why is the polar vortex a terrifying force capable of freezing the world in an instant, upending human perceptions of winter? A perennially cold front, known as the icy beast, lingers in the north. Constantly breaking free from its constraints, it extends its icy claws into the warm south. Standing in its way is an invisible yet sturdy wall of wind. This wall ensures a stable life for billions of people in temperate regions. But this wall is not permanent. Once a crack appears, the icy beast roars southward, plunging temperatures and bringing life to a standstill. What exactly is this wind wall? How can it contain a continent freezing cold front? Actually, this wall has a rather intriguing name, the polar jet stream. And the icy beast it traps is the polar vortex. Each polar vortex at the north and south poles resembles two nested giant cyclones. The lower layer, the troposphere, extends from the ground to an altitude of 10 to 15 kilometers, enveloping the atmosphere. 75% of its mass, like a behemoth, lies close to the ground. Above, the stratosphere, the polar vortex hovers higher in the sky, maintaining its own seasonal rhythm, like an icy coffin atop the beast. They whirl madly in sync with Earth's rotation, with wind speeds reaching up to 240 kilometers per hour, 3 times faster than a car speeding on the highway. Where does this frantic whirl come from? The key lies in Earth's temperature differences. The equator is like a furnace heated by the sun, causing the air to expand and rise, creating a low-pressure area below, sucking in the surrounding air like a vacuum cleaner. Meanwhile, the north and south poles are like giant ice caps, where the air freezes, shrinks, and sinks, forming high-pressure areas. Cold air rushes outward like a schoolboy running out of class. Logically, this cold air should rush all the way to the equator, but Earth's temperament makes things more complicated. The rotation speeds at the equator and poles differ dramatically. At the equator, Earth's rotation propels it at 1,600 kilometers per hour, while at the poles, this speed is practically zero. As warm air from the equator flows northward, it carries a 1,600 kilometer per hour eastward momentum, while the Earth beneath spins ever slower. This warm air, like a flung pebble, is deflected wildly eastward. This is the magic of the Coriolis effect. These eastward rushing currents eventually form the polar jet stream, an invisible chain that encircles the poles, trapping any cold air attempting to move southward. In the southern hemisphere, this chain is exceptionally strong. The Antarctic polar jet stream is as steady as steel, firmly pinning down the Antarctic vortex and preventing its near-perfect escape. But the situation in the northern hemisphere is completely different. Here, the polar jet stream is like a stretched rubber band, poised to snap at any moment. Why is the northern hemisphere's wind wall so fragile? Because the distribution of land and sea disrupts the rhythm of air currents. Temperature differences at the land-sea interface, obstructive mountain ranges, and even distant El Niño events can distort the jet stream like twisting fingers. Once disturbed, the jet stream begins to oscillate like a skipping rope, forming massive waves scientists call planetary waves. These waves grow larger and larger, eventually causing the jet stream to deviate from its course or even reverse direction. The first danger signal is a sudden warming of the stratosphere. In just a few days, Arctic temperatures could soar by 50 degrees Celsius, like someone suddenly turning on the heat in an ice cellar. This would completely disrupt the jet stream's rhythm, turning it from a reliable barrier into a traitorous descent. The westerly winds suddenly shift eastward, breaking the polar vortex's chains. Unrestrained, the polar vortex spins back like a freewheeling beast, hurtling southward with temperatures dropping to dozens of degrees below zero. The 2010 Great British Freeze is a case in point. Temperatures plummeted to -22 degrees Celsius in Scotland, paralyzing transportation, causing power outages, and killing 25 people in the freezing weather. The 2019 North American cold snap was even more devastating, with wind chills making temperatures feel as low as -50 degrees Celsius. Spending just 10 minutes outdoors could result in frostbite, leading to the deaths of 22 people. What's even more disturbing is that the collapse of this wind wall is no accident. In the northern hemisphere, 6 jet stream anomalies of varying degrees occur every 10 years. With global climate change, no one can be sure whether they will become more frequent and more intense in the future. When we complain about the cold winter from a warm room, we may never have thought that the invisible wind wall above our heads is doing its utmost to block the behemoth that can freeze the world. The polar jet stream is more than just a gust of wind, it is the amulet given by the Earth to humanity. When will this amulet lose its effectiveness? The next time the ice raises its head to the south, will we be prepared? What do you think of this life and death battle hidden in the sky?